Hi guys, I am Muchakwa Dangeni with Maths XYZ, and today we will be continuing with the concept of congruency in triangles, of which is the concept that we have started from our previous lesson. And also to urge you guys to subscribe to Maths XYZ channel on YouTube so that when we upload videos you can always get the notification. And also share this video with those that you need, that they need help with mathematics, or they actually have a course in mathematics. And also guys, if you have any question with our lessons, please just put it on the comment note, and then we'll make sure that we get back to you as soon as we can. So as we have explained from our previous lesson, that when we are talking about the congruency in triangle, we are actually talking about two triangles that are exactly similar to each other. I mean to say, that means that the angle inside the triangle, they are equal, and also the sides in the triangle, they are also equal in length, or in their dimension, I mean to say. So here we are going just straight into a question to see how we can apply the concept that we have learned from our previous lesson to answer a question regarding the congruency in triangle. Alright, here we have a question that says determine the length of x in the triangle above. So what we have here is triangle ABC, and also inside triangle ABC we have a line dividing the triangle, which is AD, which leaves that we have now two triangles inside. So the length that we are looking for, that we are asked to calculate, it's actually the length of x, which is between B and D. And by just looking with our eyes, we can actually say that x is equals to 5, because the length of between B and C looks more similar to the length between B and D. But we cannot do that without having a proof that it is actually equal. So what we need to do is to prove that the triangle of ABD and the triangle of ADC, they are actually congruent to each other. Alright, so what we have here is we have a triangle of ABD, and also the triangle of A. So guys, so just write neatly here. So what we have here is we have triangle ABD, and also triangle A, and our B head will be ACD, and this side will have reason of why we are saying angles or sides are equal to each other. Alright, so what we have here is, you can see that this the two triangles, they are actually right angle triangle, as we can see by the sign of 90 degrees there. So what we need to do is to prove, maybe if the hypotenuse are the same and the other side on the triangles is also the same, then we can prove that they are congruent to each other with the reason of right angle hypotenuse side. Alright, so what we have here is we have 30 degrees here and we have 30 degrees there. So remember when we were dealing with triangles, that in a triangle, if we have two angles that are equal to each other, that means that the opposite side to those angles, they are also having the same length. That means that if these two angles are equal, the opposite side to these two angles, they are also equal to each other. And the opposite side of angle B is equals to the hypotenuse of this triangle, which is the side of AC. And the opposite side to angle C is the hypotenuse side of triangle ABD. So that means that our hypotenuse, now that we have proved that they are actually equal to each other. Alright, so that means that the side of AB is equals to the side of AC. And reason being is angles equal, opposite angles equal in length. The opposite angles are equal. Alright, and then moving on to the second one, we have to prove that now that we have 90 degrees, we know that the angle of D1 is equals to angle of D2 is equals to 90 degrees. This one is given. We are given that. And then now that we have proved that the hypotenuse are equal, and also that this triangle is actually a right angle triangle, moving on to find another side which is equal, we can prove that AD on both triangle, they are actually, AD is equals to AD in both triangles, and reason for that is just that it's a common side. It's a common side. Now we have proved that it's a right angle triangle, and the hypotenuse is the same. Another side on the right angle is also on this both triangles, it's also equal. So that means now that we have proved that triangle ABD is congruent. Remember that this is the sign to show congruency. It's congruent to triangle ACD, and reason for that is that it's right angle hypotenuse side. This is the reason for congruency. So now we have to go back to answer the question at hand, that we must determine the value of x. To determine the value of x in this case, if these two triangles, we have proved that they are congruent to each other with the reason of right angle hypotenuse side, that means that every length in these two triangles are equal. So the length of BD and the length of BC, they are actually proportional to each other. So that means that the value of x, which is BD, should also be the same as the value of length between DC. So that means that therefore AD should always be equals to the length of DC. That means that x is equals to 5. We have proven that regarding considering that the two triangles, they are actually congruent to each other. That means that all the length, all the angles inside the triangle should also be the same. Alright guys, I hope you understood this lesson. Moving on to this example. Moving on to another example, which is this one here. So in this example here, we have this parallelogram, which is A, B, C, D, and we have AB opposite to DC, and we also have the line, which is the diagonal line dividing, which is AC. So the question here, it says, given that AB is parallel and equal to DC, so we already have something which is equal. AB is parallel and also equal to DC. So they say that we must prove that triangle ABC, which is ABC, is congruent to triangle CDA. Alright, then with this one here, what we need to do is we have triangle ABC, and also triangle, the other triangle is CDA, and this side will have reason. Okay, so the first one that we have, which is also given, is that AB, the length of AB is equals to the length of DC, and this one is given. Remember, it was written, it was told to us that the length of the AB is parallel and also equals to DC. That means that the length are also equal. Then the second thing that we must do, now that we have proven that the length are equal, we have to prove other angles or length that be equal, and give reason why we'll say that the two triangles, they're actually congruent to each other. Alright, when we are still there, remember when we were dealing with when we were introducing geometry, we also dealt with alternative angles, corresponding angles, co-integral angles, and also the adjacent angles. So in this case here, we have alternative angles in this case. So the alternative angles that we have is this C here, and also that A here. So the A in triangle ABC, and also the C, the angle of C in triangle CDA, they should be equal to each other. Reason being, these two lines are parallel to each other. So if these two lines are parallel to each other, that means that this angle here and that angle, they are actually alternative angles, which makes them the same. Alright, and then that means that we'll say the angle of A in triangle ABC, so we must have the angle inside, right guys? So it will be B, let's say it's B, and the angle of A and C is equals to the angle of okay, we can say A in triangle C and then D. Alright, then this one is equals to each other, alternative angles. Alternative angles, parallel lines. Alright, and then the other thing that we need to prove, now this time we have proven that this is equal, this is equal, then let's prove another thing which could be equal in this triangle. So we can prove AC. AC is equal on both two triangles, and reason for that is that it's a common side. It's equal on the triangle ABC, and also it's common on the, or it's equal to the one of triangle CDA. Reason being, this is a common side. This is a common side. So what we have proven here is this side, is the angle, and is the side. And on the other side, in this other side, we have proven that this is the side which is equal, this is the angle which is equal, and the side. So what we have here is we have two sides and an included angle. And even on the other side, we actually have two sides. We have two sides and the included angle there. So what we need to have now is that yes, they are actually congruent. Therefore, we have proven that triangle ABC is actually congruent to triangle CDA, and reason being, it's side angle side. Remember, if you have two sides which are equal to each other and an included angle, that means that the reason for congruency is side angle side. As you can see here, that we have two sides equal to each other and included angle, two sides included angle there. So we have proven that this triangle, it is actually these two triangles are congruent to each other. Alright guys, I hope you enjoyed this lesson in geometry, and if you have any question, please just let us know, and then we'll get back to you as soon as we can. Thank you.